In this tutorial, I'll be talking about the loading elements, the column load, load patch, and the wall load, as well as load assemblies whilst reviewing own weight and beam own weight. I will first explain what loading elements are. They are elements which apply a load on a structural member. For example, a wall places a load on the slab. There are three types: the column load, the load patch, and the wall load, as well as the load assembly, which is a combination of the wall loads together forming a load assembly. I will explain column loads. We are concerned with column loads when a column is applying a load on a raft. Thus, we have to consider it as a loading element. In the column, the MXX is to the right and the MYY is to the top, and the positive force is upwards in the column. All the different types of loading elements exhibit the same properties. So instead of the program grabbing each patch's CG and solving its moment separately, the program will view them as equivalent stress patches. All the different types of loading elements exhibit the same properties, and so instead of the program grabbing each patch's CG and solving its moment separately, the program views them as equivalent stress patches. To give you an example of a loading element, I'm going to start off with the tutorial 1, simple square slab with the 4 columns. What I'm going to first give as an example is a load patch. A load patch is a load applied on the surface of the slab, for example, a machine. Numerically, the load patch is divided into divisions. To display this, I'll apply a load patch on the surface of the slab we have. So first of all, I'm going to select the draw mode. And then make sure that you snap the grid. I'm going to draw a wall. I'm going to go to select mode and right click and select it as a load patch. Click OK. Now, to see the number of divisions in the PLGen, you can simply click on the button near divisions. Now, as you notice that it shows you NA and NB as both equaling 4, meaning there are 4 divisions in the load patch. I can change the NA and NB values as I wish by right-clicking on the load patch without selecting it. So simply right-click over here, and as you notice that I have the NA and the NB values. I'm going to click OK to close this Properties dialog box. I can also view the number of divisions in the PL view by clicking on the BE model over here. So I'm going to click the BE model, and as you notice that it opens up my model inside the PL view, and it will ask you if you want to save it. In this case, I'm going to say no, but as you notice here, the number of divisions appear very clearly. Now, the number of divisions is usually taken between 4 and 8. Obviously, the more divisions, the more solving it will take, but the more accurate the results will be. Now I'm going to close that for the meantime, and it will ask you if you want to save the input file. We'll say no in this case. And we go back to the case that we were on. The third type of loading element is the wall load. I'll go into the draw mode here, and I'm going to draw an object, say between these two columns. I'm going to go to select mode, select it, right click, I'm going to choose wall load, click OK. Notice that it only has end div equaling to 4, since the divisions are only in one direction. I can also change the number of divisions by right clicking on the wall load itself. Right click, and there we go. I have the end div at the top here, and I can change the number of divisions. Click OK to close the property dialog box. The load assembly is a combination of several walls, usually very representative of cores over rafts in buildings. In order to create a load assembly, you first need to create the walls. So over here, I'm going to create another wall here. First select the draw mode. Create another wall here. Right click. Then I'm going to create another wall over here. Right click. I'm going to go to select. Choose it as a wall load. Choose this one, choose it, define it as a wall load as well. And now, after defining them, I'll select all 3 walls and then click on load assembly at the top here. And the walls will have been combined together. Notice that the load assembly creates the same number of divisions. So I have NDev equal to 4, NDev equal to 4, NDev equal to 4 in all 3 walls. Now, if I want to explode them or change the number of divisions, I'll simply right click on them. and it gives me the number of divisions. But this is for the load assembly properties. So basically, the number of divisions, if I change the number of divisions, it changes them for all three walls. There's also a button here that called explode, which can explode the walls back into their native objects or the three walls. I'm going to click OK to close the dialog box. Concerning the own weight of an object, we will consider that an element such as a slab or a beam is a loading element in its own right, albeit indirectly, but it's still a loading element. Defining applied loads falls into two categories, the simple and the compounded. The simple is composed of the column, the load patch, and the wall load, and the compounded is concerned with the self-weight of the slab and the beam. I will open the load cases at the top here. And as you notice, we have originally set one load case for which was the dead load or dead weight, and thus it applied only on that load case, the slab own weight and the beam own weight over here. Now I'm going to close the dialog box and clicking OK. Then I'll right click without selecting the slab to open this properties dialog box. So I'll right click on it and then tell it to include its own weight by ticking this box and click OK. I'm going to go to the beams mode. I'm going to draw a haphazard beam just to show you the idea of what I'm talking about. And then right click on it, but make sure that you are in the select mode, right click, and tell it to include its own weight as well. The purpose of including their own weights is to identify the objects as loading elements, as I explained previously. And this concludes our tutorial.